Hello and welcome back. In our last topic, we have focused on Kubernetes networking. We mastered the service object, which gives us a stable load balancing cluster IP for changing group of backend pod. We have also seen how Ingress provides smart layer 7 routing for traffic coming from outside of our cluster. This leaves us one major question. How do our application find each other? In our demos, we have been using IP address to connect to our service. But in real microservice architecture, this is a trivial practice. IP can change when the services are recreated. Approach is rigid and brittle, just like you use google.com instead for mesmerizing the IP address. Your microservice needs a way to discover each other by name. This is where Kubernetes internal DNS systems comes in. The default out-of-the-box DNS server for Kubernetes is called CoreDNS. Its job is simple but essential. Automatically create DNS records for your service, so your application can use simple, stable hostname for communication. So I'm switching to terminal. The first thing to understand is that the core DNS isn't some magical hidden component. It's just another application, like our own running in a pod inside of the cluster. You can find this core DNS pod using kube, running in the kube system namespace. So let me get pods in kube system namespace and grab to the core DNS. So you can see that two pods from deployment for core DNS is running in the kube system. As you can see, core DNS is just a regular pod managed by deployment. So how it's configured? Its entire configuration is defined in a file called Corefile, and it through Kubernetes fashion. Corefile is stored and managed as a ConfigMap object, also in kube system namespace. So let me show you the config map in YAML format. So I'm getting the config map CoreDNS dash and kube system and dash o YAML. This is Corefile. This is brain of CoreDNS. It's a series of plugins that define its behavior. The most important plugin for us in right here is Kubernetes. Let me show you in the file. So here is the plugin Kubernetes. This plugin is what watches the Kubernetes API for new services and endpoint and automatically generate DNS records for them. And if you were to describe the core DNS pod itself, you would see that this is core DNS config is mounted as a volume into the pod file system as a etc core DNS, which is where the core DNS process locate for this configuration. This is classic powerful Kubernetes pattern for managing application config. So let me get the deployment from the kube system. You can see that the core DNS running here. To describe the core DNS, I'm using describe deploy, and then I'm using the deployment name core DNS. So we can see the mount point here. It is a core DNS from the config volume, and it's read only. So this is the exact thing mounting as a configuration for our application. Now let's see this is in action. The most important job for core DNS is to create the DNS records for every service. Mapping the service name it's to cluster IP. So the first demo is resolving service in the same namespace. The simplest scenario is a pod trying to connect to the service that exists in the same namespace. Let's create a namespace DNS and deploy our echo servers pod and services, and then using expose flag to for the service. So let me create ns DNS. So it's created, and then let's run the echo server and then using expose to expose it as a service as well. So the both service and pods created in ns namespace. So if I'm getting the pods dash n DNS, you can see that the echo server is running. We now have a service named echo server in DNS namespace. Let's see the service, and the IP address is 10.97.139.173. Now let's spin up a temporary busybox pod in the same DNS namespace and see if we can connect to the service using it only its name or not. So I'm using kubectl command again. This time I'm using --rm command, which remove the pod after running. So it's connect to the with wget connect to the echo server on port 8080. Success. Look at the output. Wget was able to resolve the name echo server directly from the services cluster IP. This works because the Kubernetes configure every pod DNS resolver to automatically search within its own namespace first, resolving a service in a different namespace. But what if your application is one namespace, say business, and it need to talk a database services in another namespace, let's say other? Let's create that echo server service again, but this time in other namespace. So first I'll create the namespace other, and I will run and expose the service in the namespace other. As you can see, the pod and service both created. Now let's create the business namespace and try to connect from there, just like before, using only the name echo server. So I'm going to create business namespace, and then I'm using busybox. And this time, again, I'm using, as you can see, it's running in a business namespace. I'm using echo server 8080. Let's see what's happened now. It failed. This is because the busybox pod is in the business namespace, and there is no service name echo service in that namespace. To make this work, we have to use a more qualified name. The format is service name.namespace name. Let's try again from the business namespace, but this time we will use this full name, the echo server.other. And that's worked perfectly. This is the standard, stable way to communicate between services across namespaces. The full technical name for a service, its fully qualified domain name, or FQDN, is actually service name.namespace name.svc.cluster.local. The cluster.local part is a default cluster domain. You can use this full name and it always resolves. But service.namespace is usually all you need. Now CoreDNS has one more feature you should be aware of. Two, you should use it with extreme caution. In our Corefile, we have saw the pods in secure option. This is tell CoreDNS to create a DNS record for the pod themselves, not just services. So let's get the ConfigMap. In Kubernetes module section, we can see this pod in secure option. But there is a catch. The DNS record isn't based on the pod name. It's based on the IP address with the dashes instead of dots. For example, if we have a pod in a namespace NS1, the IP address let's check the IP address of the pod in an NS1. It's 172.188.1.140. This is the IP address. So the record should be something like this. Okay, so let's use busybox in an NS1 namespace and then trying to connect to this name. So using 172.1.8 ns.local and then 8080 in the end. As you can see, it works. However, let me be very clear. You should not rely on this. Pods are ephemeral. They are designed to be destroyed and replaced at any moment. When a pod is replaced, it will get a new IP address, a new DNS record. This is the exact problem that services were invented to solve. The only reason to ever talk to a pod directly is in very advanced stateful scenarios. And even then, you almost always use a headless service to give your pod stable DNS record, which is the topic for more advanced courses. For 90% of use cases, always communicate with service, not the pod. So let's recap. CoreDNS is a cluster built-in DNS server running as a deployment in kube system. Its most important job is to automatically create stable DNS record for every service. To connect is a service in a namespace. Just use it as a name, my service. To connect in a service in a different namespace, use it as a qualified name, my service.other namespace. This simple and automatic service discovery is the final piece of the puzzle that makes complex microservice architecture possible and manageable in Kubernetes. Thank you for watching.